I'm going to quickly run through number 40 in the exercises, 9.2 exercises, and pay particular attention to the do step, the calculations. So here's the scenario. We have a situation where P is the population proportion of Alzheimer's patients who take the new drug, a drug for treating Alzheimer's disease, and experience nausea. And this drug manufacturing company wants to test the claim that 10% of patients who take its new drug will, or less than 10% of its patients who take the new drug will experience nausea. So that's our alternate hypothesis. We want to find out if there's evidence that it's less than 10% at the 5% significance level. So we're going to do a 1 proportion Z test. We have a random sample. 300 is less than 10% of the 5,000 patients that they sample from. 300 times 0.1 and 300 times 0.9 are both greater than 10, so the conditions are met. So here we are doing the test. So our sample proportion in this case was that 25 out of the 300 that they sampled, randomly sampled, experienced nausea, or 0.833%. Or sorry, not 0.833, or 8.33%. We want to know if that is far enough away from 10% that we could reject the null hypothesis. So to standardize that, what we do is we find the z-score. 0.0833 minus 0.10 is the difference between the null hypothesis proportion and the sample proportion. This is the standard deviation of the samples. This is the standard deviation of p hat. In other words, this tells you how much variability we would expect the samples to have, samples of size 300 to have if the sample proportion is really 10%. Notice we use 10% and 90%, not 0.0833 and 1 minus 0.0833, because this model is based on the population proportion of 10%. So we want to know how far away 0.0833 is. So it turns out that it is about -1 standard deviation, -0.964 standard deviations from the mean. So probably I should have shaded this a little bit differently. Let me do this a little better. So probably it's more like this, that's a fairly good amount of shading. Now I want to make sure that you understand that this is the same thing as saying this is 0.1, this is 0.0833, okay, and we have the same probability that this is under here, where sigma, the standard deviation, mu is 0.1 and sigma is the square root of 0.1 times 0.9 divided by 300. So this is the same percentage here as it is here. This is just the standard normal model where we've converted everything into z-scores. So now I want to calculate, basically the p-value, remember, is the probability that p hat is less than or equal to 0.0833 if the null hypothesis, if the true population proportion is actually 10%. This is the same thing as the probability that z is less than or equal to -0.964. So how do we calculate that? So let's go to the calculator here. Let me go to my Scratchpad menu, statistics, distribution. So we're going to go to normal CDF. Normal CDF, negative infinity, negative 0.964, 0, 1. Okay, so there's 1. Now, could we have done it the other way? Could we have also calculated it using the original values? Yeah, we could have. Statistics, distribution, normal CDF. So I could have done this, 0.0833. My mu is 0.1. And my sigma is the square root of, in parentheses, 0.1 times 0.9 divided by 300. Okay, notice we get exactly the same value. Well, slightly different because of rounding, but it's basically the same thing here. Now, let me show you one other way to do this. I'm going to go ahead and grab this and put this in my document because I want to have this in my document. And then I'll show you also the test on the calculator. So I'll deal with that later. Okay, So the other thing would be to do the actual the hypothesis test on the calculator. So I go to statistics, and then I go down to number 7, stat tests, and this is a 1 proportion z test. Now here I put the null hypothesis value, which is 0.1. I put the number of successes. Okay, so if we go back and look at this, what was our sample proportion here? It was 25 out of 100. So I got to kind of get this down here where I can put this in here. The sample proportion then, oops, wrong thing. I'll get this eventually, was 32 out of 300. No, 25 out of 300. Oh gosh, I forgot already. 25 out of 300. So here we go again. 25 out of 300. And our alternate was a less than alternate. Okay, so the probability that the actual p is less than 0.1. Okay. So I'm going to copy this and put this in my document as well. And let's compare these values to some of the things we've calculated. So if we look at this here, and I'll move it over to the side in just a minute, you see here, there's our p-value, there's our z-score, that's the z right there, our critical, that's our test statistic. There's our p-value. Notice it's a little bit different because we rounded some in these. There's the p-hat, and there's our sample size. So this gives us all of the information we need. Now, don't get your nose out of joint that the p-value is slightly different every way we calculate it, because realize I rounded this value here. And I rounded the 0.0833 here. These are the unrounded values, so it's going to be a little bit different. Okay, so bring this down here. So what do you need to show as far as the work? You need to show the sample proportion. You need to show the calculation of the test statistic, and you need to show the value of the p-value. Now, you don't have to necessarily write this information, although it'd probably be good to say that the probability that the z is less than negative 0.964 is this a value. Okay, so that's important. Then the conclusion would be, because p equals 0.167 is greater than alpha equals 0.05, we fail to reject the null hypothesis. There is not enough evidence to show that the percent of Alzheimer's patients who take the new drug and experience nausea is less than 10%. So when we fail to reject the null hypothesis, it's not terribly satisfying. We can't say anything's true. We can only say what we think is not true. Okay, so hopefully the computations make sense. I'm going to look at another one. I'll probably make a second video then. I will make a second video about another example problem where we do a not equal to and show how that's different.